One of the most important definitions in calculus employs the ratio f of x plus h minus f of x divided by h, where h does not equal 0. This expression is known as the difference quotient. All right. For now, it's not going to mean a whole lot to you, but by the end of the school year, you guys will understand difference quotients and you guys will become pros at evaluating difference quotients. All right. But in these earlier sections, the key thing is that you guys are able to evaluate and simplify difference quotients given a function. So, given the function f of x equals 5x minus x squared, evaluate the difference quotient. What this is telling us to do is to evaluate the quantity f of x plus h minus the quantity f of x, all divided by h, and simplify the expression. Notice, to evaluate f of x plus h, we are going to take every x that is in our equation of f of x and replace it with an x plus h. That means f of x, which I have shown in blue here, is going to be 5 parentheses x plus h minus parentheses x plus h quantity squared. Notice again, I have taken every single x value in my function f of x and replaced it with the entire quantity x plus h. Again, remember, when you are evaluating a function, you replace x with whatever you see inside of the parentheses. Minus, in red, I have f of x. Well, f of x is just the original function that we started with. So I have minus 5x minus x squared. One thing to make note of is that I have brackets around each one of these quantities, okay? The reason that it's helpful to have brackets around each quantity is so that you can remember to organize your work and distribute negatives as necessary. Now, the brackets technically are not needed around the first grouping, all right, but I like to keep them there anyway, just to give you guys a better idea of what you're looking at. Now all we have to do is the algebra to simplify this out. Start off, we can distribute this 5 into the x plus h. That would give us 5x plus h minus the quantity of x plus h quantity squared. Well, x plus h quantity squared means x plus h times x plus h, which we need to FOIL out into x squared plus 2hx plus h squared. So we have 5x plus 5h minus parentheses x squared plus 2hx plus h squared minus 5x minus x squared, all divided by h. We can continue with our algebra, distributing this negative through here, and then also distributing our negative to our function f of x, subtracting all of those quantities. That leaves us with 5x plus 5h minus x squared minus 2hx minus h squared minus 5x plus x squared. Now we can begin to simplify. Look for any common values that are going to add to 0 in the numerator. For example, here I have a 5x and a minus 5x. Those are going to add to 0. I have a negative x squared and a positive x squared. Those add to 0. That leaves us with 5h minus 2hx minus h squared divided by h. Finally, we recognize that we have an h that is common to all of our terms in the numerator. We can divide out an h from every single term in the numerator using the distributive property of division, leaving us with our final answer of 5 minus 2x minus h. There we have our simplified difference quotient. Let's try another example here. Given the function f of x equals 2x squared minus 3x plus 1, evaluate the difference quotient. Again, the difference quotient is f of x plus h minus f of x, all divided by h. Well, the first part of this difference quotient is f of x plus h. That means I'm going to take every x value in my function f of x and substitute in an x plus h. That gives me 2 times x plus h squared minus 3 times x plus h plus 1 minus my function f of x. Well, that's just the original function that we started with. F of x is equal to 2x squared minus 3x plus 1. We take that entire quantity and we divide it by h. Okay, we can continue with our algebra here. All right, expanding on x plus h quantity squared. As we said, that's x plus h times x plus h. which leaves us with 2 times the quantity x squared plus 2hx plus h squared. We distribute the negative 3 in. That gives us minus 3x minus 3h plus 1 minus our original function f of x. We continue to do our algebra, distributing in this 2. That leaves us with 2x squared plus 4hx plus 2h squared minus 3x minus 3h plus 1. Distributing our negative through to each of the terms in the function f of x, we have a minus 2x squared plus 3x minus 1 all divided by h. Well, take a look. Does anything cancel out in the numerator? I've got a 2x squared and a minus 2x squared. Those add to 0. I've got a negative 3x and a plus 3x. Those add to 0. And we've got a plus 1 and a minus 1. Those add to 0 as well, leaving us with 4hx plus 2h squared minus 3h all divided by h. Again, whenever you do these types of problems, you're definitely going to have stuff cancel out. If you're not having things cancel out, you probably made a mistake. Go back and check your work. So, are we done? Not quite. Notice that I have an h in every single one of the terms in the numerator. So what we can do is, again, use the distributive property of division, divide each one of those terms by h, leaving us with our final answer, 4x plus 2h minus 3. All right, one last one. Given the function f of x is equal to 1 divided by x, evaluate the difference quotient. We have f of x plus h minus f of x all divided by h. Well, f of x plus h, again, I'm going to substitute in the entire quantity x plus h for my value of x. That leaves me with 1 divided by x plus h minus 1 over x, that's my original function f of x, all divided by h. Okay, so here we have a complex fraction, and inside of this fraction in the numerator we are asked to subtract. And whenever you guys are going to subtract fractions, we have to get a common denominator. In this case, to get a common denominator, I would have to multiply my first fraction by x over x, and my second fraction here by x plus h over x plus h. That leaves me with x divided by x times x plus h. And again, no need to multiply that through. You can leave it in factored form. Factored form is always nice. Minus x plus h divided by x times x plus h. All of that divided by h. Now, we have a common denominator here, which means to subtract the two fractions, all we have to do is subtract the numerators. Notice that gives me x minus h, that's distributing each one of those, the negative to each one of those terms, divided by my common denominator, x times x plus h. And notice that I have also written the division of h as multiplying by 1 over h. All right, that is going to help us to get rid of the complex fraction. We don't want to leave fractions inside of fractions, so instead of writing this as a fraction divided by h, I can rewrite the division as multiplication. All right, I have my fraction as multiplied by 1 over h. So notice here I have an x and a minus x. Those are going to add to 0. Now I have a minus h in the numerator, and if I multiply two fractions, I just multiply straight across. This leaves me with negative h times 1, which gives me negative h, divided by x times x plus h, divided by h. And again, you will see I have an h that is common between the numerator and the denominator. Dividing that out leaves me with my final answer, negative 1 over the quantity x times x plus h. There we have our simplified difference quotient.